Hi, and welcome to the Intrepid Sea, Air, and Space Museum's live public programming, High Flying Design. My name is Kara, and I'm an educator here at the Intrepid Museum. And today we're going to be talking a little bit about how airplanes get off the ground, fly, stay there, and land safely back down on Earth. Now, just as a reminder, the museum's programs are free, but if you'd like to help us in delivering this amazing content, please click on the link in the comments below. And so today we are going to be doing a project at the end of our program. So if you'd like to grab a sheet of paper while I'm doing some introductions and maybe some scissors if you've got them lying around. If you don't have scissors, that's okay. We can tear our paper using our fingers. So again, feel free to comment in the chat. Let me know where you're tuning in from. Have you ever been to the Intrepid before? Or if you just want to answer some questions along the way. Again, my name is Kara, and I'm an educator at the Intrepid Sea, Air, and Space Museum, where our mission is to honor our heroes, educate the public, and inspire the youth. So let's get started. So like I said, I'm coming to you from the Intrepid Sea, Air, and Space Museum. We're located in New York City on the west side of Manhattan, right in between New York and New Jersey on the Hudson. Now, what's really cool about the Intrepid Museum is that it's located inside of an aircraft carrier, the USS Intrepid. Now, if you're walking down the West Side Highway, you cannot miss the Intrepid. It's about 913 feet long. You could play 3 games of football on the flight deck at the exact same time. That's how massive it is. If you were to take the ship and put it on its side, it would almost be as tall as a New York City skyscraper. From that top part that you see here in this picture all the way down to the lowest deck, it's about 8 stories tall. So like I said, if you're walking down that West Side Highway, you can't miss us. Now, the Intrepid began its construction in 1943. There we go. Right before the U.S. was sent into World War II after the bombing of Pearl Harbor. Now, the Intrepid participated during World War II, the Vietnam, and the Cold War, but also acted as a recovery vessel for NASA. Now, what would you call a large vessel that can carry aircrafts? Let me know in the chat if you know what type of vessel this is. And I hinted at it and I said it earlier. But if you can think of what this is called, it carries aircrafts, right? So if you said aircraft carrier, or you were thinking aircraft carrier, you would be correct, right? So back then, it was really impractical and really difficult to get these airplanes across the ocean. So things like Intrepid were built to carry those airplanes and kind of get them part of the way there. But what's really cool about the Intrepid, too, is not only did it carry these aircrafts, but these airplanes could actually launch and land on top, just like a runway. It's kind of like a floating airport, right? So the Intrepid served from 1943 to 1974 before becoming the Intrepid Sea, Air, and Space Museum in 1982. So let's take a look at what the inside of the museum looks like today. And here is our awesome chairs exhibit. So take a good look at these, and I'll make them a little bit bigger for you. And let me know which chair, let me know in the chat, which one do you think is the most boring chair? Maybe the most ordinary one. Maybe boring is kind of a harsh word. Let's say ordinary chair. So let me know in the chat if one of these chairs looks ordinary to you, or maybe a little bit boring. So even though there were a lot of physical jobs on board Intrepid, there were also a lot of jobs that required a lot of sitting, right? So chairs like that green one at the far right there could be found in places like offices, the mess hall, and other places that you'd maybe find like radar operators, radio men, administrative personnel. This is just your typical chair that you'd find all over the ship, right? But what's really interesting about the design of this chair is that it had to be light enough that anybody could pick it up, kind of move it around if needed, but it also had to be heavy enough to where if, you know, the ship was rocking a little bit due to waves because it is out in the ocean, that this chair isn't going to be sliding around, right? You don't want a bunch of chairs just kind of moving and sliding around the decks of the ship. So like I said, a lot of really interesting design went into this chair. So next, I want us to take a look at our chairs again. And I want you to tell me, which chair do you think is the coziest? Let me know in the chat which chair you think looks maybe very comfortable, that you'd want to get all cozy on, maybe a blanket, kind of cuddle up on, have a cup of tea, maybe read a book. Which one looks very comfortable? So I'm seeing a lot of us in the chat saying that brown chair, that set of brown chairs there, right? And this chair would actually be found in the pilot ready room. Here you can see that this is where the pilots would be getting ready for their mission. They get their assignments. They'd be kind of studying up, right? They'd spend hours in this room prepping for their assignments and relaxing in between missions. So this is where you would find some of the most comfortable chairs on the ship. If you look really close to, and in our chair picture too, you can see that there's a compartment at the bottom as well where they could store their materials. If you come onto the ship today and come visit our museum, you can find what the pilot ready room would have looked like during the 1960s and 70s. So back to our chairs here. Can anybody in the chat tell me the chair that they think is intimidating or a little scary? Maybe it makes you feel a little uneasy or it makes you feel uncomfortable. One that might make you feel intimidating, or it looks intimidating. I see some of us are saying the second chair, right? If you look really closely, that chair has a lot of straps. Right? It's got the big metal pieces on it. It almost looks like you have to wear a seatbelt when you're in this chair. And this is actually an ejection seat. So let's say that our pilot got in a little bit of a bind, right? You'd find this chair inside of an airplane. In the event that something happened and he needed to make a quick getaway, he would pull that lever at the top there. It's yellow and black striped, or he'd pull it in between his legs. And basically this mini bomb or small explosive would go off underneath, and the chair and the pilot would kind of burst out the top there, right? So that canopy would come off. Sometimes it wouldn't, and they'd have to go through it anyways. You can see in this picture here, there's a lot of glass, right? So like I said, this mini bomb would go off. It would launch that pilot and the chair in. The pilot and the chair would separate. He'd use his parachute to help slow him down, to kind of create some drag, right, to help him slow down before landing in the ocean. Now, chairs like these came during the jet age, closer to the Vietnam War. So going back to our chairs here, let's say that our pilot, right, used his ready room chair where he learned about his assignment. He goes on his mission and gets in his airplane. Right? He's over the ocean. Something happens. He needs to make that quick getaway. He pulls on his lever. He's ejected out of his airplane. He uses his parachute to float back down into the ocean. But the Intrepid's not anywhere near. He's picked up by another ship. So he's got to get back to the Intrepid, right? That ship calls Intrepid and says, hey, we have your pilot. Come pick him up. Intrepid gets there. And these two ships are side to side, right? Just right next to each other. Can anybody see a chair here that might help that pilot get from one ship to the other? And I'll give you a hint. It would look a little like this. So maybe you want to talk and turn to a friend, kind of talk about what you're seeing here. Right? If you look really closely, you can see that this chair is kind of like on a zip line. This is called the Highline Chair. And basically, this is how you would get from one ship to another if you were not on Intrepid and that's where you needed to be. You'd sit in this chair. There's a cable that would go through the top circle of the Highline Chair, and it would get you from one ship to the other. Right? As you can see here, you can see those waves crashing onto the ship. Both of these ships would be moving. You kind of have to think about, well, if one of these ships is going faster than the other, that ship is going to pull the line, and that pilot in the middle there is not going to be happy. If these two ships get too close to each other, they're going to dunk that pilot in the water. So it's actually kind of very adventurous to go on this Highline Chair, if you ask me. Right, let me know in the chat if you'd actually like to take a ride in the Highline Chair. Fun story we like to tell at Intrepid. One time, one of our pilots got on another ship, needed to get back to the Intrepid. And the Intrepid was known for having these really big freezers, right? It's a really large ship. And so that ship tells Intrepid, hey, we'll give you your pilot back if you send us over some ice cream. And Intrepid goes, sure, not a problem. Wink, wink. And they actually put ice cream in the Highline Chair, but they weigh it down with soap shavings and send it across. The receiving ship didn't find it funny, so when they sent our pilot back over, got a little closer and dunked that pilot in the water. Personally, I feel bad for that pilot. I don't think it was his fault that he got dunked in the water, but what you gonna do? Awesome. So I think now would be a good stop to have a question break. Does anybody have any questions? Any questions? How many people served on Intrepid? So Intrepid had about 3,200 men to about 3,500 men. These men served on board for about 6 to 9 months, and they were really young. They were about 18 to 23 years old. And this was the first time a lot of these men were leaving their houses for the first time or leaving to be on Intrepid for the first time. So it was a really big deal. It was also very scary to be away from home for that long. Good question. What is the black and green chair on the far end? Oh, so let's go back to those chairs. See if I can get us there. There we go. If you look at that green chair at the end there, right? Circle it for us right there. Have we ever seen a chair like this before? Anybody in the chat want to tell me if they've seen something like this? These men were on board for 6 to 9 months, right? That's plenty of time to get a toothache, to get a cavity, right? You're supposed to get a teeth cleaning every six months. So there was always a dentist on board. Like I said, they were on here for about 6 to 9 months. So everything that you would need on land or maybe in your community, you'd also have on board the ship as well. It's kind of like a city at sea, right? A community at sea. So there was always dentists, right? There was doctors, there was surgeons, there was a post office that these men could write back to their families. There was a general store too. So like I said, everything you'd find in your community, you'd find on board as well. Good questions. Awesome. So I did mention that we are going to dive into learning a little bit about how airplanes fly, which brings us to our Avenger, right? Our Grumman TBM Avenger. Now, this is one of the primary planes of World War II, and it's also the oldest plane in our collection at the Intrepid. Its main purpose was to carry and drop that 2,000-pound torpedo that you see right underneath it. It was a torpedo bomber. This plane could hold 3 people. It held the pilot, the radio operator, and the navigator or the tail gunner. Now, let me know in the chat if there's anything about this plane that you find particularly interesting. Maybe something about its design, its color, the way it's built. Let me know if you notice anything just interesting about it. Of course, the first thing that I notice is that its wings are kind of interesting, right? A lot of people think that these wings are broken, but they're actually folded. So if you want to try this activity with me really quickly, you can take your hands and you can put your hands wide out as far as you can, right? Take those airplanes and I want you to turn those wings, and turn side to side. I'm already having a really difficult time. I hit a wall. If I go too close, I'm going to hit my screen here. But I want you to take your airplane wings now and I want you to fold them in for me. Now turn side to side. Did you hit anything that time? I definitely didn't hit that wall or even my computer screen, right? Intrepid could hold about 100 airplanes between the flight deck and the hangar deck. So trying to get these airplanes to fit together was really difficult unless you could fold those airplane wings in and fit more airplanes as well. If you notice, the coloring of this airplane is very interesting as well. It's got a white belly underneath, and it's got that dark blue on top. So imagine that this airplane is flying over you. If you're looking up at the Avenger, that white belly is going to kind of blend in with the clouds. If you're another plane flying over the Avenger, that blue top of the plane is going to blend in with the blue of the ocean. Right? So this plane wasn't very fast, right? It only went about 276 miles per hour. So it had to get as much camouflage and help to make sure that it was hidden from the enemy, right? So like I said, it went about 276 miles per hour, and its wingspan was about 54 feet long. So this is a really large plane. If you can see that person there, it looks really small compared to the size of this airplane. It was really large, like I said. It didn't go very fast, but it was also very heavy. It weighed about 18,000 pounds, right? So going back to those wings and looking at those wings folding in, being able to fold your wings adds a lot of mechanics and a lot of extra weight to this airplane. So you're probably thinking, you've talked about how heavy it is. How does it get off the ground? How does it get off the ground, fly, and help it land safely? Right? So aside from its wings and its landing gear and all these extra pieces, it needs some help. That's where our 4 forces of flight come in. So as we're looking at the Avenger here, can anybody tell me what this piece is called right here in the front of the plane? Let me know if you know what that's called. It starts with a P, turns in a circle like this, and goes really, really fast. Anyone in the chat tell me what that's called? I see a couple of us are saying propeller, right? And that is a propeller. But propellers are not only found on airplanes, they can also be found on ships. Intrepid had 4 propellers, and basically these are what help the airplane move and the ship move in the forward direction. It provides our first force, which is thrust. So basically the way it moves, or the way it works, in the case of our ship here, right? Think about if you're swimming. Some of us might swim like this. Some of us might swim like this. And what's happening is you are pushing that water backwards, having your body move forward, right? So same thing happens on an airplane propeller, or with an airplane propeller as well. So air is kind of like water in that it's a fluid. It's not water, but it's a fluid in the way that anything that flows is considered a fluid. Right, so going back to our propeller here, the same way that a propeller works underwater works on the plane as well. As that air is being moved around, it's actually being scooped, pushed back, and helps the airplane go in that forward direction, giving us thrust, the force that moves us in that forward direction. Now, you're probably thinking, I've been to the airport a million times and I've never seen a propeller plane, or the planes that I've seen don't have propellers. So how do those airplanes move forward, right? You've probably seen an airplane that looks a little like this, right? And this is a jet plane. And these jet planes have jet engines, and they don't have propellers like planes like the Avenger, right? Here, this Fury, you can see generates thrust a little bit differently. Basically, the way a jet plane works is these airplanes take in a big gulp of air. They basically go, that air moves down the belly of the airplane. It mixes with jet fuel, and then it's ignited. That ignition blasts out the back of the airplane, generating thrust to move the airplane forward. So in the case of the Avenger, the propeller gives it thrust, but in the case of our Fury, the jet engine gives it that thrust to move it in that forward direction, right? So thrust is the force that moves us forward, but let's think about the force that holds us back. Can anybody think of that force that holds it back? Kind of mentioned it when we were talking about our pilot and his parachute. The force that holds you back. Imagine that you're running outside and you've got something hitting your face, kind of holding you back from moving in a forward direction. If you would have said drag, you would have been correct. Drag is generated by a fluid, air, hitting on a solid object. In our case, it's going to be our airplanes, right? Now, there has to be motion. If our airplane isn't moving, then there's no drag being created or anything holding it back or hitting the airplane. You kind of test this out too. If you take your hand, you wave it back and forth like this, you're going to feel a lot of drag and a lot of air hitting your hand, right? Creating a lot of air resistance. If you take your hand, kind of go like this and cut the air instead, your airplane or your hand's going to be able to go through that air a little bit better because you have less surface area. So we know that thrust is the force that moves us in the forward direction. We've got drag that holds us back, right? But we've also got two more forces, right? We have the ones that come down and the force that takes us up as well. So I mentioned a little bit earlier about how heavy the Avenger is, right? It said it weighs about 18,000 pounds. It's also carrying a 2,000-pound torpedo. It can also fold its wings with all that added mechanics, makes it just very heavy, right? So it's got to combat something to get it off the ground. Can anybody tell me in the chat the force that holds us down to the ground that we have to overcome in order to get off the ground? If I asked everybody in the chat to stand up and jump in the air and stay there for 5 seconds, could you do it? Let me know in the chat if you know that third force that we're going to be talking about that holds us down to the ground. You might have said gravity, and if you did, you'd be correct, right? Gravity is that force that holds us down to the ground that keeps us from floating away. The heavier you are, like the Avenger, the harder it is to get off the ground. Gravity is going to be working against you. But gravity also helps us maintain control of how high we can go as well. So thrust moves us forward, drag holds us back, gravity holds us down to the ground. We need one more force. Could anybody in the chat tell me what that force is? Anybody know that force that gets us off the ground, takes us up? So today we're going to be looking at a closer view of our Fury here. So as we walk around this plane, if you were to come to the museum, you can see that there is a cross section here of the wing. Now this particular shape right here, it kind of looks like a teardrop or maybe an eyebrow, right, is called an airfoil. And it's designed a very certain way so that as this plane is moving in the forward direction, air is going over and under the wing. It's actually split, right? A little bit over and a little bit underneath. Now, during the 1700s, there was a scientist named Daniel Bernoulli, and he basically found that air going over that wing is moving a lot faster than the air moving underneath. So you have faster air on top and slower air on bottom. That faster air on top creates an area of low pressure, and the area on bottom has high pressure. Now, the thing about high and low pressure is that high pressure always wants to get to the low pressure. So when enough of that pressure is generated, that high pressure, it actually lifts up our airplane because it can't go through the metal. So it actually lifts it up, helps that airplane get up into the air. Now, there's another scientist, principles at work here, right? Sir Isaac Newton, we've probably heard about him. And his third law of motion says for every action, there is an equal but opposite reaction. So as our airplane's cutting through the air, that air on top is actually being deflected downwards, causing our airplane wing to go up. So like I said, you have Daniel Bernoulli and you have Isaac Newton's principles at work here when it comes to our airfoil. There we go. So you can see a little bit closer here that as that air is going over, it's also being cut underneath. On the top, you have that faster air. On bottom, you have that slower air. Low pressure on top, high pressure on bottom is able to lift this airplane and get it up into the air. And that is our fourth force, right? Lift. It's what actually helps us get up into the air. So as we look at our last force here, you can kind of see these a little bit better. Thrust is the force that moves you in the forward direction. Drag holds you back, right? Our air resistance. Gravity holds you down to the ground and keeps you from floating away. But our airplanes have to combat that to get enough lift to get us up, to get them up in the air. Awesome. So these four forces, depending on what they're acting on, can actually be in different directions. I hope this doesn't break your brain. But if you're looking at maybe an ejection seat, right? The thrust is being generated and going upward, right? Thrusting this pilot to get him up in the air. If we're thinking about that pilot coming back down to Earth, our drag is actually hitting on the top of that parachute. So instead of drag maybe hitting the airplane in the face, this drag is actually in the upward direction. So depending on where these forces are being generated, they can actually be in different directions. They're not always up or down or side to side. Now, these four forces, we can get the airplanes to do some pretty amazing maneuvers, right? They don't just turn left and right. They don't just go up and down. And it requires a little more than your basic parts of an airplane, the propeller or the jet engine or the landing gear or the nose, or I think I said propeller already. You need a couple more things. That's where our control surfaces come in. So again, we're going to walk around our Fury here. And as we walk around, you can see this long piece here. It kind of looks like a little flap. This is called our aileron. And our ailerons are what help control the roll motion, or that side to side, kind of left and right. If you're kind of rolling down a hill, imagine it like that. As we walk to the back, you can see these horizontal flaps here, and those control pitch. These are the elevators. So just like an elevator in a building goes up and down, our elevators on an airplane control the up and down motion of the airplane as well. If you're looking at this yellow flap here, that is our rudder, and it helps the airplane move side to side or do the yaw motion. Now, you've probably heard of a rudder on a ship too. Same thing, that rudder helps control the side to side motion on the ship as well. All right, so it's a good place to stop for a question break. Does anybody have any questions? How many planes fit on Intrepid? So about 100 airplanes could fit on Intrepid between the flight deck and the hangar deck. And so like I mentioned earlier, we have planes like the Avenger and the Fury that can fold its wings up or maybe back to make room for all of these planes. As we go further into the jet age and during the Vietnam War, we could actually hold less airplanes because jet planes got a lot heavier. So they could actually, Intrepid held less planes going into the Vietnam era. Good question. Any more questions? Do all planes use airfoils? Yes. So that special shape is what generates enough lift and get these airplanes off. So maybe not... Every airplane will have that airfoil shape too, especially when we look at helicopters in just a little bit. If you pay attention to their rotors, or if you go to the museum, take a look at all of our airplanes on board, because every single airplane is going to have that special airfoil shape, including rotors on helicopters as well. Good question. So moving on, right? I did mention that the flight deck is where our airplanes took off and where they landed, right? So if we imagine, there we go. Imagine our flight deck here. Intrepid is about 900 feet long. If you think about airplanes that take off from airports, those runways are thousands of feet long. There is not a lot of space for these airplanes to take off and land. Taking off from the Intrepid was pretty difficult. Steam was generated in the engines and actually taken up to the flight deck, compressed, and these airplanes were basically slingshotted off the front. They couldn't generate enough thrust and enough lift to get them off by themselves, so they needed a little bit of extra help from those steam catapults that, like I said, basically slingshot them off the front of the flight deck. Now, thinking about So taking off from the Intrepid is called a cat shot. And basically these airplanes would go from 0 to 150 miles per hour in just 2 seconds. So very, very fast in a short amount of time. Now, landing on the ship is just as difficult. So you have to imagine that the ship is moving through the water at about 40 miles per hour. It's also probably rocking a little bit if it's really choppy water or there's a lot of waves out there as well. So these pilots have to actually land on basically a moving target that's kind of shifting as well. And the way it basically worked was these airplanes had a tail hook right underneath them, right? And so you can see on that right hand picture there, that tail hook is white and black. And they basically put that tail hook down, and they have to try and catch these arrestor cables stretched across the top of the flight deck. And you can kind of see that on the left-hand side there. Basically, these airplanes would land, they try to catch that arresting cable or arrestor cable, and they're about this thick steel cables that would absorb the shock of these airplanes landing on top. And like I said, Intrepid's about 900 feet long. And of that 900 feet, there was only about 250 feet of landing area on that flight deck. So they didn't have a lot of room to land on there, right? And these airplanes are coming in at about 130 miles per hour as well. And like I said, their job was to try and catch those arrestor cables that are stretched across the flight deck. So you can see here a little bit better picture of the tail hook dropping and this pilot trying to catch one of those cables stretched across. So I did mention earlier that we were going to take a look at some helicopters, right? One of our helicopters at the museum, this is the Sea Guard. But as you can tell, or as you may have seen, right, helicopters are really special in that they don't need a runway like the Avenger did or the Fury did, right? Helicopters can vertically take off and land, which means they don't really need a runway. You can just go up and just come back down. Now, looking at this helicopter here, just by looking at the colors, can anybody in the chat tell me what you think this helicopter might have been used for? I notice it's red and white, and there's a little bit of blue in there. You can also see there's a basket underneath. Can anybody think of maybe vehicles in their communities that are also colored like this, maybe what their jobs are? And see if you can figure out what the Sea Guard's job is. So if you said a search and rescue helicopter, you would be correct. So this helicopter was used to rescue people who might have been drowning, who might have been out in the water. They would release this little basket underneath called an Erickson basket. Basically, they'd scoop up that person and bring them to the top. But what's even more interesting about this helicopter is that it's basically amphibious. If you look at the front there, you can see it's shaped like the front of a boat. It also has sponsons on the side that kind of act as buoys. This airplane could actually this helicopter could land in the water and take off from it as well, even in some really horrible weather. Over the 26 years that the Sea Guard was used, it rescued about 15,000 people. So it was a really amazing helicopter. If you visit our museum today, you might notice that this plane is grouped with our helicopters. Let me know in the chat if you know why this airplane would have been or is grouped with the helicopters at the museum's exhibit. If you look really closely on the side there, you can see that this airplane has maybe what looks like gills, right, or vents. And what's really neat about these vents is they can actually turn about 90 degrees. They can push air down. Just like a helicopter, this Harrier Jet, can actually vertically take off and land. Now, if it's fully loaded with all its weapons and all the stuff it needs, it's actually a lot better for it to take off on a runway. It's a little bit easier for it to get off the ground. It's kind of really difficult to get enough thrust to push it off the ground in order for it to take off. It's a little more efficient to use a runway than to do a VTOL. Looking at another one of our really interesting planes at the museum, this is our A-12. And just by looking at it, let me know in the chat what you think its job might have been. You can see maybe from the color, from its design, the way it was built. Let me know in the chat if you know what the job or the purpose of this airplane was. So as you can tell, just by the way it's shaped, it goes really, really fast, right? It doesn't have a lot of drag. It doesn't have a lot of air resistance. It's very aerodynamic. It's very sleek, right? If you notice, it's also painted black because it's trying to camouflage at night. You might have guessed that it is a CIA spy plane, and this is the fastest airplane in the whole world. It went about Mach 3, or about 2,300 miles per hour, basically 3 times the speed of sound. So it went very, very fast. It could go from Washington, D.C. to California in just over an hour. It's about 102 feet long, and it has about a 55-foot wingspan. So it's a really long plane. It goes very fast. Like I said, it's very aerodynamic. It's very sleek, and it doesn't have a lot of air resistance as well. So moving on to our last plane that we're going to look at today, this is the Concorde. And just like the A-12, it's kind of designed in the same way that it's very skinny, it's very flat. Earlier when we were doing our little hand experiment, if you wave it back and forth, you're going to catch a lot of air, you're going to feel a lot of air. But if you take your hand and put it on its side like this, you're going to feel less air resistance, a little less drag, because you have less of a surface area. Same thing with these airplanes like the A-12 and the Concorde. And just like the A-12, the Concorde is the fastest commercial jet, which means that basically if you had enough money, you could buy a ticket on this plane, where the A-12, you'd probably have to be in the CIA in order to fly it, right? So like I said, it's the fastest commercial jet. It went about Mach 2, or about 1,400 miles per hour. You could go from New York to London in just 2 hours and 54 minutes in this airplane. Now, this airplane retired in 2003, and in the 1990s, flights for this airplane were about $6,000. So you had to be very wealthy in order to be able to buy a ticket on the Concorde. Awesome. So now is a good place to have a question break. Does anybody have any questions? What happens if a pilot missed the cable for the landing? Oh, so if that pilot comes in, he's going to land on Intrepid, and he just cannot get one of those arrestor cables. There was more than one. There was about 5 that would stretch across. If he missed that cable, he'd actually have to keep going, fly around, and do it again. So as he's coming in, he's not going to slow down. He's still going to be coming in at full speed just in case he misses those cables and has to do the whole thing over again. Good question. Why don't we use the Concorde anymore? So like I said, buying one ticket, one-way ticket in the 1990s was about $6,000, which meant if you were getting a round trip ticket, it was about $12,000. It was very expensive to ride on this plane. It was also very expensive to maintain. It used up a lot of fuel, and it wasted a lot of fuel. And like I said, very few people could actually afford to fly on this plane. It just was not cost efficient by the end of its time. Good question. Awesome. So friends, I did mention that we are going to do an activity. So if you want to grab your paper and grab your scissors, we are going to get started here. Make this a little bigger for everybody here. So what you're going to want to do is you're going to lay your paper flat right in front of you. Make sure you have your scissors. Like I said, if you don't have your scissors, that is okay. You can use your hands and your fingers to rip. But what we're going to do is we're going to fold our paper in half. And we're going to kind of do it like hot dog style. Just make sure it's got a nice crease right down the middle. And you can get that just by folding it in half. Next, we're going to make our nose of our airplane. And we're going to take that top right-hand corner and just line it up with the center that we created when we folded our plane. So it's easier too if you think about grabbing the top right line and making sure that line lines up with your half in the middle. Next, we want everything to be as symmetrical as possible. So we're going to take the opposite side, or the left-hand side, and fold it down so that it's along that middle line, but also touching the right-hand side. So it should look like a little roof by the end. Make sure that it's as equal as possible. I'm using construction paper, so it's a little harder to fold. But next you're going to want to take the diagonal, the right-hand diagonal. You're just going to want to press it towards the middle as well, lining it up with that center fold of your paper. So again, the right-hand diagonal there, and just line it up with the center of your fold. Again, we want it to be as symmetrical as possible. So you're going to do it to the opposite side as well. Just make sure you grab the left diagonal and line it up with the middle of your airplane. Make sure those creases are nice and tight. It'll help your airplane be more aerodynamic if everything's folded in nice and tight. Next, you're just going to want to fold it in half. Make sure those folds are inside, in the inside of the airplane. And our plane can't fly without wings. So what you're going to want to do is take that top part and line it up with the bottom base of your airplane. Create a nice wing that lines up down there. Again, make sure it's nice and tight. You don't want any of your folds coming undone. We want our plane to be as sleek and aerodynamic as possible. Again, we're going to make it as symmetrical as possible, flipping it over and making sure that our plane has 2 airplane wings. So make sure it lines up with the bottom. Awesome. So you can kind of floof those airplane wings up a little bit, tighten it up, make sure it's nice and pointy. Now is where you're going to want to grab your scissors, because earlier we talked about our control surfaces on airplanes. So we're going to go ahead and add some elevators. So all we're going to do is we're going to just take our scissors and make 2 little slits on the wings. And you're just going to want to gently fold them up. So don't tightly fold them down, because you could put them up, you can put them down, have both of them up, both of them down, have one down and one up. But that way you have some elevators on your airplane there. So if you'd like, you can toss your airplane and see how it flies, and then add some elevators and experiment and see what happens if one's up and one's down, both up. But let's go ahead and add a rudder as well, right? And that's going to have our airplane move side to side. Again, you don't want to fold it down too tight, because you might want to experiment, fold it the opposite way as well, and see what your airplane does. So go ahead and toss your airplane and see what the different control surfaces do and how it flies. So thank you so much for joining me today. The museum has introduced a number of live programs that you can find on our website at intrepidmuseum.org, or you can subscribe to our channel as well. Our next program is going to be this Thursday, June 3rd at 3 p.m., Golden Record, Messages from Earth. Come learn a little bit about the Voyager space probes and the golden record that went to space with recordings from here on Earth. Now, just as a reminder, the museum is open Thursdays through Sundays from 10 to 5 p.m. So definitely come check us out and see some of the really cool aircraft that we have. We also have the Growler, the submarine, and we also have a space shuttle as well. So definitely come and check that out. If you liked this program, we invite you to answer our quick survey located in the chat or the comments. Again, my name is Kara, and thank you for joining me on today's Intrepid Adventures.